I'd like to introduce Jennifer Huck, Sherry Lake, and Eric Pripper of all of University of Virginia, who will be presenting practical reproducibility instruction, teaching reproducibility with technical and non-technical tools. Take it away.
Good morning, everyone. Hi, thanks for coming. I'm so excited to talk to you today about this workshop series that we created at the University of Virginia. Sherry, next slide. All right, so here's a little bit of information. Oh wait, no, I should introduce myself first. I'm Jennifer Huck. I'm the data librarian and acting associate director of research data services at UVA Library. I'm joined by Sherry Lake, the scholarly repository librarian, and Eric Pripper, a science and engineering research librarian. Here's a little bit of context about the University of Virginia. We're an R1 university. There are about 23,000 students, and there are 12 schools. And only the School of Data Science has a policy for open access and open data, and that is very new as well. Some context for UVA Library. Our team members come from scholarly communications and the research data services and social, natural, and engineering sciences teams, which are two teams from different units within the library. Research Data Services has a long-running workshop series on tools for quantitative and qualitative data analysis. And one thing to point out, it is very rare for library staff to teach 4-credit courses at UVA. So teaching within a workshop series like this one is one of our best chances for instruction. All right, so what do we do? In spring 2021, UVA Library's Research Data Services launched a new workshop series called Reproducible Research for early graduate students. The overall concept was to enable researchers to improve data use and reuse for collaborators and themselves, to use available technical tools to create reproducible workflows, and to communicate and disseminate findings and data. The initial target audience was early graduate students in STEM departments. The 4 workshops in the series focused on both technical and non-technical tools for reproducible research. Our technical sessions covered tools and workflows, and our non-technical sessions covered file and metadata organization and data sharing. So how did we do it? Each semester, our Research Data Services team presents an extensive suite of workshops taught by our staff, as well as collaborators from other units throughout the university. We offer training on technical tools such as R, Python, Tableau, and Deduce. We launched our reproducibility series as a standalone mini-series within that workshop environment. We are fortunate to have a lot of staff at our library with some facility and data, so we are able to pull in librarians with varied skill sets. Our sessions were a mix of old and new workshop content. Of the sessions in our reproducibility series, one was an existing workshop, one was a mashup of old and new content, and 2 were brand new. And as for outreach, we advertised the sessions in our Research Data Services newsletter, which goes out to interested readers at UVA. And we also reached out directly to communications directors at various schools who then pass along this info to their students. And we had 2 presentation formats. In the spring, we presented virtually via Zoom, and in this fall, we presented in person.
Hi, I'm Sherry Lake, the scholarly repository librarian, and I'm going to talk about the 2 non-technical sessions that we did. The workshop series started with the non-technical workshop, Organizing Files and Metadata for Transparent and Reproducible Research. In this workshop, participants were instructed on fundamental approaches on creating a research compendium, which is the foundation of transparent and reproducible research. Participants learn what kinds of documents and materials they should create, preserve, and what type of information the document should contain, and how they should be formatted and organized. Topics for the workshop included organizing raw data files, data analysis files, documentation, scripts, metadata, README files, project organization, and naming conventions. The examples were based in R, but no programming experience or experience with R were required, as the information learned in the workshop could be applied to any quantitative programming environment. The last workshop in the series was sharing your data for transparent and reproducible research. This workshop covered tools and resources on sharing research during a project, which included an introduction to the Open Science Framework, OSF. And the second part included sharing at the completion of a project. The last part was broken down into why, where, what, and how to share data. Starting with an overview of why share, which included, among other reasons, the need to share for transparency. It included where to share, on how to pick a repository for sharing data, which I introduced the FAIR principles as a way to select a repository, again, with an emphasis with the importance on reuse and how it relates to transparency. What to share covered the important topic, what can't be shared, and included a list of UVA's policies related to data collection and data protection. The workshop concluded with how to share by emphasizing that sharing starts with a data management practices, a data management plan.
Hi, my name is Eric Perper, and I'm a research librarian. So I'll start talking about the technical workshops that we offered. So I taught the workshop on version control using Git and GitHub. So basically, version control is used to manage code development individually or in a team setting. And in the context of this presentation, version control is really important because basically it's a complete record of everything that has happened in your code base since the beginning of a project. So it's all transparent and it's all available. We first made sure that everybody was up and running with GitHub, a GitHub account, and also Git locally on their own machine. So then we walked through common workflow scenarios using these tools. We started by first tracking our code changes locally using Git, and then eventually pushed them to a remote GitHub repository. And then later we walked through collaboration scenarios as if you were like a team of developers working together. So we talked about branching, pull requests, and things like that, where you can work together collaboratively.
All right, we also had a session on RStudio and R Markdown. In this session, we reviewed RStudio projects to create a project-oriented workflow in R. We also provided an overview of R Markdown for literate programming. This highlighted the new features of visual R Markdown, which makes using R Markdown much easier and has some great new features like making citations easier to do in R Markdown because it connects RStudio to Zotero. All right, so how can you do it? Here's some takeaways for you. Look for partners to collaborate with on a series for reproducibility. One person doesn't have to and should not have to do it all. I know I personally can fall into this trap, so I try to be really intentional to build out a team of other people here at UVA Library that could partner on this. So, and here at UVA Library, we also partner with colleagues outside of research data services and outside of the university library. For example, in this case, we collaborated with librarians like Sherry, who's not part of the research data services team. Additionally, we also in the past have partnered with our health science library colleagues who have their own separate research data services team, as well as research computing. The colleagues there offer a wide variety of more advanced computational workshops. And we all have various levels of technical expertise. So some technical experience is definitely helpful, but you don't have to be a data scientist to teach in this area. I consider my skills in R to be emerging, but I found that that was enough for me to see the value in tools, especially in RStudio, or concepts that might be overlooked or not formally taught in a classroom. Not all of these tools require a strong statistical, data science, or programming background in order to teach them. Like I'll never be a statistical consultant here at our library, but I know enough to see the value in some of these tools. Also, look around for existing workshops at your library that you can market or rebrand to fit into a reproducibility theme. Like this is one example that we have is using our Get and GitHub section to like rebrand it to fit into this reproducibility theme. Are you already doing workshops or events, other things that you could use for this purpose? Sherry's going to expand on this idea on the next slide too. Finally, all of our workshop material is openly available. Take our stuff. There is no need to create all the materials from scratch. Note that the version control workshop is a combination of previous workshop materials plus online content that was created externally.
5 minutes.
Okay, I'm just going to sort of elaborate on Jen's previous point on taking materials you already have and repurposing them, such as taking typical data management and sharing workshops and converting them to transparency and reproducibility workshops. So in thinking about the transition, doing research with an eye toward transparency, being fair, and managing data management are overlapping but distinct concepts, and each emphasize different aspects of handling and sharing research data. Research data management is not a goal in itself, but a set of practices to handle information collected and created during research. Us librarians, we know that research data management is the compilation of small practices that make data easier to find, easier to understand, less likely to be lost, and more likely to be usable during a project and 10 years later. So in slight contrast to data management, FAIR and transparency both focus on data sharing, ensuring that content is made available in ways that promote access and reuse. But data that is not managed cannot be successfully shared and reused or is necessarily transparent. So we can't forget about data management. It is needed before the data can be faired and shared, and it enables data to be created and used in such a way that increases transparency and helps in sharing and reuse. I want to suggest that maybe by using the more appealing language of fair, findable, accessible, interoperable, reusable, and talking about transparency, reproducibility, or organizing research, you can engage researchers in data management without actually mentioning that sometimes confusing phrase. I want to point out that Jen did not use the phrase data management at all in her workshop title or her presentation, but file organization, file naming, documentation are all data management 101. The way we presented the more catchy concepts of transparent and reproducible research and sneaking in data management concepts without calling them that is a useful way to engage researchers and encourage good data practices from the start. It might open up conversations with researchers in ways that dull, old data management never did.
So we compiled a bunch of resources to start with, and all these links that you find here are links to either our own materials or to other materials online that we use to build our workshops. So this is for you to check out later if you're interested in doing this at your own school. Next slide. And concerning feedback and assessment, basically what we did is we tracked attendance and we follow up with all of our attendees after the workshop. So to expand on that a little more, graduate students are our target audience and the most common attendee type, but we have a lot of attendees who were also postdocs and research scientists, which we didn't expect. And we also have faculty members, undergraduates, community people, other staff around the university. So there is a pretty good variety. And historically, in the pre-COVID times, we held these workshops in person and attendance has traditionally been good. Sometimes the room is packed out completely. During the pandemic last year, obviously things changed and we had taught our workshops online, still with pretty good attendance. This semester, the university is pushing hard to go back to normal, in quotes. So we've been offering our workshops in person again, and attendance has been not very good. And we feel it's probably for a combination of reasons. People feel like it's a little too soon, but we were sort of forced by the university they forced our hand to offer things in person again.
1 minute.
All right, looking forward. So what else can we do with the work we've done here? We would consider trying to take this to specific departments by reaching out directly to directors of graduate studies. We might also find other seminar series at UVA where this could fit into. And a final idea is to find faculty reproducibility champions who might want their grad students to learn about these concepts and come teach a lab directly. All right, so that's pretty much it. All our workshop materials can be found at OSF. There's considerably more references to learn about each individual topic in the workshop series. And we also have a research data management services Zotero group library if you want to dive into that more. And yeah, that's pretty much it. So thank you so much for coming to our talk today. And yes, feel free to ask us any questions. Thank you so much.
And we did get the first question about the resources, where to find the shared resources. And Sherry, thank you very much for putting that into the chat. So anyone who wanted to access the workshop materials could see that.
Yeah, and as long as we have this references slide up, the very last one, the National Center for Ecological Analysis and Synthesis, that was one that I happened to come across as I was like initially learning more about reproducibility. They have a full week-long series, and that was part of the light bulb moments for me was I realized like, hey, we're like already teaching almost all of this, but how can we like reframe it so that, you know, this place charges $2,000 for a week-long course. Like, how can we frame what we're already doing, add a few more of those like non-technical courses to like put a bow on it and say, this is for the folks interested in reproducibility.
It's the slides that we just presented are also on that OSF project. So it's the slides we presented today along with all our materials for the classes that we taught in the workshop. Lots of links.
I see a question from Lene. With your online workshops, do you record them and then post them anywhere? We do not record our workshops. We've pretty much been in the habit of not recording them because we want to keep things a little bit looser and informal, especially when people ask questions. But you know, with this like brave new world of like, we're kind of still on Zoom, but not really, we're in person. Some people seem to have liked the Zoom format. We may have to reconsider the recording situation. Okay, you mentioned that this is a question from Andrea Pritt. You mentioned that your primary audience was graduate students, and I was wondering how experienced or inexperienced you found your grad students to be in these areas. Did grad student attendees express comments like, I wish I learned this earlier, or anything like that? I have to say, I didn't like personally hear any of those kinds of comments, but that was kind of what I was hoping to push out with this content too. Like, you know, all the stuff you wish you had learned, like the most important things nobody's ever taught you, like to keep yourself organized. And I did think it was interesting, as Eric had mentioned, we did have like postdocs and research scientists attend. And initially I did find that kind of surprising because I thought, you know, I was kind of pitching this to more of an early career student. But so I kind of wonder what the reaction would have been if I had been able to talk to some of those folks, you know, in person after the workshop, but that was in the Zoom times. So I guess I can't be sure.
And I'll answer the next one. How much interest and uptake have you had for OSF? Not much at the time. Certain departments like our psychology and our biomedical engineering groups seem to use it a lot more. But UVA is now a member institution of OSF for institutions. And that is something that we're hoping to gear more direct outreach and in the first of the year. We're just trying to get OSF to send out that email and to all of our EVA email addresses.
It looks like that's the end of the questions, and we're very close to the end of the time. So I want to thank all of you. That was really, really great and a wonderful way to start the CETLs. And that was my alarm. Thank you so much.
All right, thank you, everyone.
Thank you,
Have a great
Nina. Thank you,
conference.
Now we're going to switch, and our next, there we go. I see Allie now. Our next short talk is Allie Kirsten. Allie, have you gotten the promotion? Okay, I see you. Wonderful. You should have the power to share your screen now. Allie is going to talk about introducing scientific data pipelines to novice students, another great topic. By the way, while Allie finishes setting up and going to presenter mode, if that's what they want to do, I just want to say briefly here, we had amazing applicants this year. I mean, really, it was really very difficult to select people. Thank you so much, Allie, and take it away.
Well, knowing how competitive things were this year, I'm very honored to be able to talk to you here today. So my name is Allie Kirsten. I am the Research Data Management Librarian at Auburn Universities, and I am also the Geosciences Liaison. So I'm in a department primarily of subject liaisons, and that will help to explain how I got this particular in this particular course. But what I'm here to talk to you about today is introducing scientific data pipelines to novice students. And this is not a group that I am as accustomed to working with personally. I tend to work more with graduate students or researchers or undergrads who are a little bit further along. But I've always had an interest in working with beginning students, especially in the area of data literacy. And so when this opportunity arose, I was very eager to jump on it. But I'd like to back up a little bit first and think about some of the initial problems that one might confront when you're trying to introduce, say, a data workflow to people for the very first time. Because for us, it's kind of fluency for us at this point for many of us, and it can be difficult to back up to realizing exactly where someone is when they're starting out. It's complicated by the fact that both the concepts and the practical skills can be brand new to these learners, and so it can be tricky to balance giving them an understanding of what they're doing and also leaving them with something that they can actually carry out and take over to the next time. We know that one-shots have very limited staying power, so to speak, and there are good alternatives, one of them being actually integrating this data literacy instruction into a regular course. But this is difficult to do. So when a librarian such as myself gets that opportunity, I was very eager to jump on it. And in this particular case, for this talk, we're going to be talking about a lab in a core science course here at Auburn. So what course was it? Well, this is a brand new course. It's a two-part course called Global Systems. Weather and Climate is the first part, and it's being offered for the very first time this fall. And the second part of the course will be more about sort of the ground side of things. I like to say that the fall semester is sky, and the spring semester will be the ground. But the important thing to note is that this series is aimed at first and second year students who are not intended science majors. Now, of course, the Geosciences department would love to attract some majors with these courses, But for the most part, we have been getting students who are interested in things like a business degree or elementary education. But one of the things to note about these core courses here at Auburn is that they have to target specific student learning outcomes that the university has determined are necessary by the time you graduate. One of them is apply scientific principles. Now, to me, data literacy is a very important aspect of scientific literacy, especially now. And as I was talking with the instructors in geosciences about this course, they had very kindly come to me to help develop the course and talk about the kind of resources we might use. I was able to suggest that we could do a lab like this, and they very graciously allowed me the opportunity to essentially run my own lab within their course. So that was the opportunity that presented itself. So I was really left to my own devices to develop this lab, and I used some existing material, but I primarily developed it on the basis of other introductory research data management workshops that I had done. The twist was that I needed to develop a lab around data that was relevant to the course. And so that's where the course instructors actually told me what it was they wanted me to talk about. So with that guiding principle, I was able to sort of pull the lab together, but I also used the templates that every other lab in the course was using. So I wanted to be consistent with the 9 other labs that are being offered this semester. And then to develop all of the labs, the instructors and the TAs, everybody who was involved in the course, met regularly over the summer and really right up to when we started in August offering this course. And we talked it out, sort of workshopped these labs, and feedback was given and I made changes. And so this was the process in which I developed this lab. So what did we actually want to do? The lecture topic that this lab was going to follow on from was the air quality index. And so the air quality index is something that I needed to learn a little bit about. I had a general sense of what it was. Having once done research in China, I was acutely aware of which levels were considered unhealthy and justified staying indoors on those days. But you know, AQI data is not something that students are really going to be collecting for themselves. We did talk about crowdsourcing and we did talk about community collection of environmental data, but a key point of this lab for me was to give them some pre-constructed AQI data in a somewhat friendly format, you know, not locked up within a sensor, that they could play around with. So I actually did create pretend AQI data that you'll see shortly. But we had a couple learning objectives for this lab. We wanted students to be able to understand not just the AQI data itself, but how we got to that point. We know that in science, it's so important to grasp how we come by the knowledge that we have. And so I really wanted the students to get a sense of, this is what we measured, and these are the things that happened in order to get us this AQI value. And then I wanted to let them actually try that. And I did explain that, you know, these things are typically done by machines within a machine, especially to generate these dashboards that we went through in class. But to try the basic steps, this was something that I felt that they could do. And so I set this lab up in such a way that they could actually try for themselves. So in order to do the lab, we brought them over to the library. Most of their labs are elsewhere, but I wanted to make sure that everybody had the same equipment. I wanted every computer to already be set up with Excel in particular, because not every student had Excel loaded onto their personal computer. My teaching philosophy is kind of to try to abstract away any details that are not going to be relevant and could potentially interfere with the instruction. And so having Excel pre-installed, having all the computers, you know, wired up was important to me in that respect. And then each lab session was 2 hours. So that told me that this was going to be a little longer than the sessions that I typically run, which are about 50 minutes with time for questions. This pushed me a little bit to have more content maybe than I'm typically doing at once. And keeping in mind that it's a 2-hour session, I really wanted to keep it moving and keep the students engaged, which we know is not always easy to do. The course instructors were in attendance for the first session. And then in the second session, the one teaching assistant stayed, and then a couple of my library colleagues were actually able to observe, which was another great way to get feedback. So we started right where the students' lecture, which had just occurred that morning on AQI, picked up. And the first thing I had them do was go through these 2 particular dashboards, which you're free to take a look at on your own as you like, and point out specifically how the coverage was achieved, or rather not achieved. For instance, I pointed out to them that the data supposedly for our location here in Auburn wasn't actually coming from Auburn because we didn't have a station in Auburn. And then I particularly drew attention to the measurements and the units. And this is an example of what they would see. And if you look down there in the lower right-hand corner where it talks about a specific pollutant, PM 2.5, which is very small particulates, I pointed out that concentration, that 18.2 micrograms per cubic meter, because I wanted them to understand what was actually being measured rather than just this index value that they were using as a measure of whether the air was healthy. Speaking more of the conceptual level, the concept I wanted them to be introduced to was data typing. And so I thought if I wanted them to understand data typing, I would show them the 4 basic measurement scales that you may be familiar with: nominal, ordinal, interval, and ratio. And I wanted that to help warm them up for the notion of data typing in Excel. And so we actually got to the activity in Excel after we played around with these dashboards. This is what I presented the students with. If you have time later, you can go ahead and take a look at this and play find the errors. But that's essentially what we did. Is I let the students look at this, and they had this sheet to play with. So they weren't just observing it and telling me how to fix it. They had their own copy on their own computers that they then went ahead and played with, did their best with to make it, for instance, data that could be machine readable. There was a second component of the lab that I did not get to with them for reasons that will become clear in a couple slides, but we did make sure to go through Box with them because Box is the cloud storage solution that Auburn offers. And we showed them, since they were on computers that were not theirs, how they could upload all the files that they'd worked on to Box so that they wouldn't lose all that work. It wasn't just a matter of uploading it to Canvas. We wanted to make sure that they retained their files. So how did it go? It seemed to go pretty well. And by the end of the lab, students absolutely understood that Excel was something that they would probably need to get better with. And it was at least planting the seed of, oh, I'm likely to see this in my future work. But the thing is, the first section in particular, that 11-to-1 section, we had to spend a lot more time with getting them up and running. There were a couple computers that weren't working, so we had to switch them over to other machines. And just during the course of instruction, more things came up. So as a result, we didn't get to the second activity in the first section. We did have time for it in the second section. We just chose not to do it to keep the experience consistent. So that tells me that the material that I developed was appropriate for the time period, but not if there is a serious delay. So that's something to keep in mind as you pace your sessions.
1 minute.
Thank you. And then things that you might want to keep in mind as you do these materials for yourselves, here are some of the lessons that I learned. We lost time to technology glitches. It would have been helpful for me to attend the lecture that morning. I wasn't able to in this case, but if you can attend the lecture that goes with the lab, that helps to avoid overlap of material. The 4 measurement scales was way beyond where the students were at. So keep in mind with the conceptual material, you've got to put it where the students are coming from and not go too beyond their abilities where they are. And also, we were trying in the midst of the lab to figure out what the actual assignment was supposed to be, because we had some confusion. I thought they were only going to hand in the one thing, and then the instructors asked them to hand in both things. Fortunately, the instructors were able to facilitate that and explain it, but it did add some confusion that I would have preferred to avoid. So I do know that we are just about at time. The lessons learned are basically a wrap up, and this slideshow will be made available so you can read these on your own time. But I'm just going to skip to future directions, that if you get an opportunity like this to work within a course and to do a graded activity in the course, you really should jump on it. Reaching out to faculty as they're building a new course is a great time to do that. That's a good entry point. And I was really fortunate that I was able to use my relationship with these faculty in my liaison department to become a partner with them in this. So I think that's the end. And now I will take questions.
While people are typing their questions into the Q&A box, I have a question for you,
Yes.
Allie, because this is really interesting, and because I can't type in the Q&A box. Any idea why they had trouble with the data types? And I don't actually know the air quality index. Is there a lot of nominal or category oriented data that goes in there?
Yes, actually. One of the things, even on the sample data sheet that I gave them, is things like location. So instead of having a lat long, right, I just made up an example. I said sort of Auburn High School versus the stadium that we have here. And then I wanted them to see that they needed to make those place names consistent. And then that could also be used to introduce the idea that in the documentation, you might have to specify for people who don't know what Jordan-Hare Stadium is, you might say Jordan-Hare Stadium is located at XYZ. And so, yes, all of the data types did play in with this AQI data, but the main thing that I wanted to get across to them, which I think I overcomplicated it, and if I had just explained it in a more straightforward manner, they would have gotten, is that the direct measurements of concentration of pollutants in the air, that microgram per cubic meter measurement, that is what is being measured. That is a real number. That is a ratio measurement. But the AQI itself is just an index. It's in some sense an arbitrary number. And I just wanted them to understand the difference between the physical measurement that the sensor would read and what gets reported as this is a good air day or this is a bad air day. And we also went over which pollutants were contributing to the AQI that day, and that it could be different if one day particulate matter was a concern and then another day the nitrogen oxides were a concern. And they did get that. The way that I tried to construct it was too much for them.
Allie, this is great. We have a couple of open questions now in the Q&A. Can you see those? Or would you like me to-
can.
Great.
Yeah, so this first question that I'll answer is from Jen Huck. Can you expand upon what you learned about how to teach data typing and or measurement? So I did, I think, cover that a little bit in my answer to Nina, but just to make sure that I answer this question specifically, it needs to be strongly tied to the course material. So the fact that they were learning about AQI that day was a good entry point. And also with the measurements, I think maybe don't overload them with too too detailed of an explanation, really distill it a bit down to the essence. For example, this is what is being measured in these units, and only give them additional background information, maybe if they ask. So I have another question here that I can take. This is from Amy. Great integration of scientific coursework. However, do you think it would be good to start more basic intro to Excel or working with data first as a prerequisite? You said they were non-science undergrads. Yes, that in an ideal world would be something that they would have had, because one of the things, it got blown through a little bit in my lessons learned, but they actually did need basic help with, can I make this column bigger? You know, really basic questions, or how do I highlight this? So we did have to go through some of that. However, in this specific case, the instructors were aware. First of all, they had the decency to tell me that this might be the very first time some of the students were seeing Excel, which I appreciated knowing. And then they specifically told me that they wanted this to be an entry point for Excel, with the understanding that the students would be using it down the line. And even though these were non-science majors for the most part, they were likely to be using it in their fields, in their professional work, in their pre-professional work, even just later here in their coursework at Auburn. So yes, in an ideal world, they might have had a little more preparation with Excel, but the instructors were very upfront with, this is how we'd like to show it to them.
Thank you. Thank you, Allie. Thank you, question askers. I appreciate it. What a great launch. Our first session has been amazing. It is time for a short break. So we will be audio silent for the next 15 minutes, and we'll return at 11:15. Thank you all.